Hello students, good evening.
Good evening.
Yes, good evening. So yesterday we have started with this feedback. Now I just draw. Please ask.
So, this character, emitter and base, they are only classified on doping and thickness values.
What did you say? What was it? Come again?
So, collector, emitter and base. They are called like they depend on the doping and the thickness. And the type of semiconductor also. Okay. Yes.
But okay na kya na? Wait. Right. Okay. Now you see, I am going to draw a block diagram. This is called block diagram. Okay. So now you see, I have got something here which is called mixer, or you can also call it as adder. Right? I'm going to do like this. So here I am giving the input or the actuating signal, and this will go to this amplifier. Okay, and then you are going to get the output. You are getting the output, right? Okay, now try to understand this. So this I will say plus, that means the input is coming here and you are getting the output. Okay, this is simple. Now what I will do, I will tap a part of the output. Okay. See, there are 3 people waiting. Oh. So I am tapping this feedback network. Feedback network, and I will tap a part of the output, and I am going to give it here. I hope you understood this configuration here. This is called mixer. Pardon? I am tapping a part of the output and feeding it back to the input. Okay. If you have any confusion, you ask her. Don't hesitate. Okay. Now the question is, if I say like this, that means what? A part of the output I am feeding here what is called as negative input, or this is called negative feedback. That is, see, this signal, this feedback signal I am adding to the input which is out of phase, and therefore I am writing it as minus. Did you capture this sign convention that I have put here? You have to say yes, no, wait sir, we didn't understand, some response.
Why negative first?
See, because I want to have a concept called negative feedback. Okay, negative feedback means a part of the output I am feeding it out of phase with the input. See, now for example, yesterday I gave an example. Your friend is depressed and he wants to start drinking. Okay, that is what he wants to do. Now, what are you going to do? You are going to tell him, don't drink. Understand? That means you are giving negative feedback to him. Right? And supposing you encourage him to drink, then you are doing what? Positive feedback. You are getting information from him. That is, his output is, I want to drink. Now, you will get that information that he wants to drink. What will you do? Will you encourage him to drink? If you encourage him to drink, then you should make it plus. Now, if you are discouraging him to drink, then you will make it minus. Got it? Negative feedback.
Here, how encouraging is explaining
Okay, I will explain. I'll explain. I'll explain. See, the other day I gave a small example to you. You remember this for stabilizing the amplifier? You remember for stabilizing the amplifier? You remember? So what did I do here? I added a resistor here in RE. You remember? So if the collector current increase, okay, the collector current increase, the base current is fixed. Now if the collector current increases, this VE will also increase and VB will not increase. But this IB now will be what? VB minus VE divided by this IB is VE minus VB, of course, divided by whatever it is, divided by this resistance. I hope you remember this.
Yes.
So now if so this IC is dependent on what? IC is beta times IB, beta times IB, and beta is temperature dependent. Okay, so if temperature increases, beta will increase, IC will increase. If IC increases, then this voltage V will increase, that is this voltage will increase, and therefore IB will decrease, and therefore now IC will settle down to its original value. So here you see, yeah, here SLS. Okay, right, good. So here, what am I doing here? See, I am taking, see, this is the output, IC is the output. Hello? This IC is the output. I am passing this IC through RE, okay, and the effect of this, you can see the effect of this, which is affecting what? This current IB. So here, if this increases, this will decrease. Therefore, it is called negative feedback. Everybody understood this?
Yes, sir.
See, you see students, I am not exaggerating. You can open your NCERT book and see. Transistor as an oscillator, positive feedback, negative feedback, vagera they are given. And whatever is given in NCERT, you must thoroughly, profoundly understand it. Because you are going to answer big ticket examinations like mains, NEET, IISc, advanced, whatever it is. So they are not going to just ask you superficial. They are going to make sure that you have profoundly understood it. So therefore, all these things are extremely important for you to understand. If you have any question, please ask. There is nothing like, I have understood 99%, sir, I will manage the examinations. No, sir. If you have understood 100% only, you will get marks. If you have understood 99% and try to answer, you may end up with negative marks. Okay, so you have to put that effort, you have to be brave and bold. Right. So this is the concept of negative feedback. Okay, understood? Hello?
Yes, sir.
Now, on the other hand, I can have some configuration. See, here I am showing you, for example, this configuration. Okay. Now, I can show you some other configuration. I can show you some other configuration, right? And well, I don't want to go into the details of some other configuration here. I can create a feedback which is positive in nature. Okay? Hello?
Sir, this increases, that will also increase.
Pardon? Yeah. If the output increases, if this output increases, okay, then what happens? This will also, see, this signal will also increase. If this increases, again this will increase, and again this will increase, and therefore it's a compounding effect.
Yes, sir.
Okay, so that is what is the thing. So this is negative feedback, positive feedback. Now, as far as negative feedback is concerned, I have written a circuit and I have explained to you. I hope that is clear.
Yes, sir.
Okay, done. Good. Okay. Now, before I proceed further, I want you to. There is one more point I wanted to touch upon. Yeah. Now, here you see, because I went through some question paper. Okay. So in the question paper, of course, there is V in here, and there is RL here, and there is VCC. I suppose you understood what I have written here.
Yes, sir.
This is VCC, means there is actually a battery. There is actually a battery like this. I am not showing this. I am just showing VCC here. Yes. And of course, there is a V in here like this. I am not showing this. I am directly showing V in here. Okay. Now you see, I will tap the output from here. I will call it as VO1. and I will tap the output from here. I will call it VO1 and VO2. Okay, hello, are you with me? Now, if I tell you that the input impedance seen from here is Ri, okay, now tell me, what is VO1 equal to? I am tapping the output from this point.
VO2 minus Ri into.
No, don't use VO2. Just tell me VO1, output voltage VO1. Okay.
VCC minus.
No. I want you to tell in terms of Vin. I want to tell you in terms of Vin.
Can we use VO2, sir?
No, don't use VO2. Okay. Now there is no much time for both of us to deliberate. So see, VON is nothing but AV into V. Correct now? Hello?
Yes, sir.
So what is AV here? It is minus beta RL upon RL into V. Correct now?
Yes, sir.
This is what I wanted you to tell. Correct? Okay. No problem. Yeah. Of course, if I give you more time, you would have come out with this answer, I'm sure. But anyway, we are all under pressure, time limitation. So I've got to clarify this. Now, what is VO2?
Like we can use that alpha and gamma.
You tell me. See, listen. I am helping you to learn. Okay. See, I have taught you some concepts. I have taught you some terms. Okay, and I have taught you how it works. You know electrical circuitry. There are so many things that you know. Now you just see. Okay, I want to know the voltage of this point that is voltage at the end in the response to V. See here, I have written VO in terms of V. I want you to write VO2 is equal to what?
So VO2 will be gamma times.
Okay. Gamma times something you want to tell. Okay. No, don't complicate it. Don't complicate it. Simple. What is this voltage? This voltage. Okay. What is this voltage? So this is Vin. Vin minus the drop here is this voltage. Correct?
Yes.
And this voltage minus whatever drop happens across this is this. Right? Now, if you consider that this current is very small, then for all practical purpose, this Vin is here. For all practical purpose. Okay? And so your VO2 will be what? Vin minus V cutting. That is V cutting voltage because we have forward bias transistor. Correct? Isn't it? Now again, if you neglect this, see, now if you are talking about delta VO2, then you will talk about delta V. And then if you talk about delta V, this will not be there. So you can see here, any change that occurs here will be reflected in the output. Correct? VO2 will exactly be equal to V. Okay? So here you see, if you are tapping the output from here, the gain of this amplifier will be 1. Got it? Voltage gain will be 1. There is no gain. जितना आपने अंदर इनपुट दिया उतना ही बाहर आया. So gain is 1. Output upon input is 1. Both are equal.
But when that IB will increase, sir, IC will also increase. No.
देखो. See, you must not become a stereotype. अंदर एक IC यूज करके करना ही है, इसको यूज करके ऐसा ही करना है, वो निकाल दो आराम से. अभी देखो, ये जो वोल्टेज है, this voltage is there, minus this drop is this voltage. It is circuit, man. Current is flowing there. Why are you worried? See, now, this is what is analysis. You see voltage, current, resistor, all that. Now here you see, if you keep the voltmeter terminal here, it will show 1 voltage, and there is some drop here, and it will show this voltage. And if you neglect the drop, so is this. So therefore, the gain of the amplifier is 1 under this circuit. That is, if you are tapping it from here. Correct?
Yes.
Okay. But if you are tapping it from here, the gain will be this, with the minus sign. I hope you can appreciate the minus sign. Because it is out of phase. This is in phase. Correct?
Yes.
See, let us run. I am not simply teaching you something here like that. This question is asked in exams. Okay, I am just, I had actually put it in the, in the corner. I suddenly remembered that I am just teaching you. Like that, there are many things associated with this. Anyways, we have limited time. With that, what best I can do, I will do it for you. So I suppose you are able to capture some things like this. Now you must be very good. See, that's what I am trying to tell you. This chapter will put to test whatever you have studied so far. Electrical circuits, electrostatics, current electricity, okay, and so much of semiconductor physics, etc. Everything will be put to test. So you just have to be alert, aware, brave, bold, confident, and just use science and try to give answer. No exaggeration. Okay? Yes, you need some training to use these quantities. I will do my best to ensure that within the limited time, what best training I can give you, I will give you. Okay? Okay, great. So, shall we proceed, students?
Yes.
So, negative feedback, positive feedback, I told you. Right. Right. Now don't read anything here. Okay? Please only concentrate on this circuit. Right? You just concentrate on this circuit, and I will tell you what we are going to do. Right. Now, you see, I have something here, right? And I give VCC and I ground it. And I am going to get the output here. And this output will be, this output here will be like this. When I close this switch. When I close this switch, I am going to get this sort of an output. Okay. So what is this? This is nothing but an oscillator. Okay, you just turn on and you will start getting oscillations.
VCC is a DC voltage.
Whenever, say, gentlemen, come on, whenever I have written VCC, it is the DC voltage only. Why do you think it is? Okay, got it. VCC means DC voltage. Sorry. Great. So you see, you are giving a battery and suddenly you start getting the output. This is an oscillator. Okay, we are going to generate oscillations. That's it. We are going to generate the sinusoidal signals in the laboratory, in the working place. Okay. Now you are going to learn what is there inside this. What is there inside this is what you are going to learn. And electron, see, now henceforth, the design is like this. This is called the block diagram. So, okay, this is a dabba. It has got something inside, and it is going to do this. Now, what is there inside this? That's what we are going to learn. Okay? Yes. Now, answer my questions very, very carefully. Right. Then only, you can understand this work. Now, here, you see, this is the swing. You know swing now?
Yeah.
Jokali.
Yes.
So you are standing here. Okay, and then you're standing here, and then your little brother, sister is sitting on this, and now when you leave your head, what happens? So this is making an angle θ1. If you leave, now you are going to do something very real, not ideal condition. So you leave your hand, what will happen? Just tell me what will happen. Nothing to think. What will happen?
It will start with theoretical.
Step by step you tell. As soon as you leave, what will happen?
It will come to gain some energy.
It will gain some energy.
Velocity.
Velocity. You should tell properly. It will gain some velocity. Okay. Then what happens?
It will move forward.
And then what happens?
The other side will reach the maximum height and come back.
So it will reach the other side. It will reach the other side. That's what I want. So I'm just going to draw it like this. Now, what is this angle? I'm telling you a real situation. What is this angle?
It will be a bit less than theta.
Good. So this is going to be theta 2. And theta 2 will be less than theta 1. Correct?
Okay.
Why?
It has factors like air resistance.
Air resistance, friction here, and all these things. So it has lost some energy. Fine. And then what happens?
Come back.
See, this is where I'm training you. Come on, even a small bacha will tell it is come back. But that's what I want to answer from you. Now you see, I have now pointed you as the angle is theta 1. It will move to the other side and it will make an angle of theta 2 and then start coming back. Correct now? See that theta 1, theta 2 is important. Now what happens?
The other side will reach an angle which is bit less than theta 2.
Less than?
Theta 2.
Theta 2. Okay, theta 2, fine. Less than theta 2. I will do. That means this is going to come and be here. Correct? And this angle I will take it as theta 3. This angle I will take it as theta 3. Correct?
Yes.
Now what will you do? What will you do? See, you want your little brother to actually play the swing for quite some time. Then what are you going to do?
Apply some force.
Pardon?
Apply some force.
Apply some force. See, it is not some force. You are going to do something there and ensure something. You are going to push this person here in such a way. See, in such a way that this person will again come to this position. आपने धक्का दोगे, इतना ही धक्का दोगे कि your little brother will come to this point. Correct now?
Yes, sir.
See, you see, man, this is physics, man. You got to imagine, you got to be real here. So you are going to give push here. In such a manner, again it will come here, and again it is going to come back here. Again you are going to push again. So it flips on.
Yes.
Now what is important is, when are you going to push? When are you going to push? When your little brother has come here and he is about to go here, at that time you push. All this is important. Your little brother has come and now he has come, he has stopped and about to go like this, that time you give a push. So you are giving you are pushing him in phase. He is going like this, at that time only you are pushing. So you are applying force in phase. Did you capture what I told?
Yes, like how do you define in phase?
How do you define?
In phase or
if you are in front of me, I would have made you to swing and see. In phase means, देखो भैया, ये swing जो है ना, ये इधर आया. इधर आने के बाद क्या हुआ? इधर आने के बाद क्या हुआ? इसका velocity 0 हुआ ना? और उसके बाद it has just started moving like this. It has just started moving like this. At that time, you are pushing it in the same direction. Is it not in phase?
Yes, in phase.
Understood the meaning of in phase?
Yes, sir.
So, there are two things that you are doing here. What is it? You are giving a push, ensuring that you are in phase. And you are giving delta E energy. How much energy are you going to give? Delta E. And what is delta E energy you are going to give? What is the magnitude? See, the body was here, it came here and it stopped here, correct? So why? That means now it's, see, when it was here, its energy was mgh1. Now its energy is mgh2, correct? Everybody say yes or no. Yaar. See, I am with lot of love and affection I am teaching you. You see your own college, what they have done. You want education like that? See, because you students are like this, no teacher would like to teach you students. They think that the students are not interested. And when a teacher is trying to teach interestingly, you are not at all, enthusiastic. You are simply keeping quiet there. See, you should do your duty properly. God, the nature will help you. You cannot simply sit like that in the class like that. You have got to be you have got to take responsibility. Responsibility is all about responding, not reacting. Understand? So you have to respond. Right? Then only you will get knowledge. Nature is not going to give you knowledge just like that. You don't think that whatever knowledge you got till 7th standard, the same thing will happen now. You are all small children. You are less than 12 years. Okay? So less than 12 years, you are all children. Now you are not children. You got to put the efforts. So how much energy are you going to give? The energy that is lost. See, this went here and came here. It lost some energy. So you are going to replenish. You are going to give energy to the system. How much energy? Whatever it is lost and in phase. Then only the oscillations. Okay, then only the oscillations will sustain. Take your brother will be arms swinging. Tuck, 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 tuck. And you keep pushing. It's called sustained oscillation. Neither it is increasing nor decreasing. So, if you convert this into a sinusoidal signal, it will be a beautiful sinusoidal signal whose amplitude is constant. Understood? So this is called sustained oscillation. So now you see you are going to do something like this here. Because whatever transistor, resistor, etc. you do, some energy will be lost. It is, see, even a transformer, we say V in is equal to, see, Pi is equal to PO. But there are transformer losses. PO will not be equal to Pi. Like that, any machine for that matter. There is no machine which is 100% efficient. All of you know. So, this is also a machine. It will not be 100%. And this is also a machine which is not 100%. So, if you replenish the energy that it has lost, that too in phase, then the oscillations will be sustained. Did you capture this point?
Yes, sir.
Okay, that is point number 1. Now, you see, you are giving that external energy or external force in phase with the system, isn't it? In phase, correct?
Yes.
And that is what we call it as positive feedback. This is what you are giving in phase is called positive feedback. Did you capture that?
Yes, sir.
Now having done this, see, you have given this delta E, you are giving positive feedback. And the system by itself is, because of the gravity, it keeps moving up and down. Gravity is also playing a role. Gravitational force is playing a role and you are giving the force. So now, if you look at this whole thing as a system, the gain of this system is 1. See, if you consider yourself also to be an internal energy, that is, if you consider this whole thing as a system, that is, you are also an insider, then what is happening here? The energy of this system is neither increasing nor decreasing. Oscillations are sustained. Correct?
Yes, correct.
Then the gain is 1. There is no increase in the amplitude or decrease in the amplitude. So the gain is 1. The loop gain is 1. So what I want to tell you here is something like this. So here you see the loop gain is 1. right? Then only the oscillation is sustained. Okay, understood?
Yes, sir.
Good. Okay, now stage by stage or step by step you should understand. Okay. Now, you see, what I will do? I will take a transistor, right? This is the common point. And, well, what type of transistor is this? This is PNP transistor?
Yes.
Huh? No, man. This is
Which is this, sir?
This is the NP. See, I am writing the arrow here. That means if you forward it. See, whenever we write this, this is always base. Who is that fellow who is asking who is base? You write like this is already base. Okay. So now, right, so this is NPN transistor, correct? Hello. So therefore, I am going to have a battery like this. Okay. And then you see, I am going to build a tank circuit here. I suppose you can recognize these symbols. What is this symbol and what is this symbol? This is capacitor and this is inductor.
Yes.
And I am going to connect it to this. Okay, before I do that, I am going to have a switch here. I suppose you understand now? This is a switch here. Yes, well, this is a switch here. Okay, so this is an inductor. Now, if I draw a line like this and do like this, then you know what is this? This looks like a transformer. And if I draw a double line here, it means it is on a core. On a core, you have both the windings are on the core. Okay, right. And then, well, I am going to connect it like this. Okay. Now, if I close the switch, what will happen? Now, if I close the switch, what will happen? Nothing will happen, because IC will flow. The current IC will flow only if there is base current. Got it? Simple, man. The logic is simple. Current will flow if only base current is. Otherwise, it will not flow. Correct? So, you see, this transistor is acting like a switch. This transistor is acting like a switch. Right? This transistor is acting like a switch. Okay. So, this is what happens. Now, I am going to draw one more coil here. And I am going to extend this coil. Right? So, I will call this as T1, I will call this as T2. Now, what do you understand when I have drawn the line like this?
The core is extended.
Okay, continue. That's not sufficient.
The power supplied by that T1 is distributed.
No, see here. So, if you say this is the core, hello, core means, you know, its permeability is very less. Okay? So, I will have one winding here and another winding here. T1 is here. This output is also here. Hello? And I will put the third winding also here. That means I have got a core on which there is winding number 1, winding number 2, okay, and also winding number 3. Got it? All the 3 windings are on the same core. Got it?
Yes.
Okay.
Understand now? It's there in your syllabus. All the 3. That means now, see, if the current flows here or here or here, it is going to create magnetic flux, and that magnetic flux is going to link this, this, and this. In any of the coils the current flows, it is going to create magnetic flux, and that magnetic flux will link all the 3 coils. That's the idea. Got it?
Yes, sir.
Yes, sir.
Okay. Right. Okay. So now you can see the positive, negative. So the positive terminal of the battery is connected here. Now you can see here that this is winding 1, winding 2, winding 3, and winding 1, winding 2, winding 3. And now this is positive and this is negative. That means now the current will flow like this through this winding. It will come here and it will go to the base. That means this is providing what is called as the base current. Correct? Okay. So what happens now when the switch is open? When the switch is open, the base current will flow. Of course, there is some resistor here and all. You have to show that resistor here. That is not shown here. This is just a resistor to limit the current. So some base current is flowing into this transistor. Correct? Right? Hello?
Yes, sir.
And how much current? What will be the collector current if the switch is open? Collector current is 0.
Yes,
Base current is flowing, collector current is 0. Correct?
Yes,
Right. Now if I close this switch, so this is VCC, this is VB. Now if I close the switch, what happens? Come on, see now all that theory you have learned. Now that this switch is closed, what happened?
So like at that instant or?
Okay, you okay, from that instant I close onwards, what will happen? You tell.
IC will increase like steadily.
See, I'll tell you. If you want to be a good engineer, good professional, you should go in steps. You should feel every moment. Understand? You should capture the time and space and you should explain both these dimensions. So as soon as you close the switch, what happens? This is an inductor. Current cannot rise in the inductor instantaneously.
Yes, sir.
But this is a capacitor. Current can rise in that instantly.
Yes.
So therefore, as soon as you close the switch, this VCC, current cannot rise here, but current can go here. So the current initially will travel through the capacitor like this. Okay? ठीक है क्या नहीं?
Yes, sir.
हाँ. तो स्विच होने के बाद जर्क करके करंट विल पास. There is nothing stopping. तो क्या होता है? If current flows through the capacitor, क्या होता है? क्या होता है बा करंट कैपेसिटर से पास हुआ तो बोलो उतना ही फिजिक्स इज ओनली सो मच सो कैपेसिटर विल गेट चार्ज कैपेसिटर विल गेट चार्ज so how much will be what happens if the capacitor is charged?
Current stops flowing.
Hey, what happens if current starts flowing through the capacitor? It gets charged. What happens if it gets charged? Potential will rise, man. Useless fellow. Potential will rise. No. See, that's what I'm trying to train you people. You don't want to do like this. You want to by heart and vomit in the exam. You don't want to think. Come on, start thinking. It's so simple. Physics is the easiest subject in this universe. You just have to follow. That's it. So current will flow, it will be charged, and so the voltage will start rising. Correct?
Yes, sir.
What is the maximum voltage it can go? See, this voltage will start rising. See, this point voltage will start rising. So when this point voltage with respect to this becomes VCC, then the current through the capacitor becomes 0.
Okay.
So this capacitor now will be charged to VCC in this direction. See, that's important. So in this direction it will have VCC. Correct?
Yes, sir.
Then the current will have no other go but to start flowing through this coil. So current stops here, but current starts flowing like this. Initially, actually, current will slowly, but current cannot rise instantaneously, so current will slowly start flowing. Initially, one rush of current is there, but then what happens? This inductor says, "Hey, नहीं, मैं तो current को छोड़ूंगा, लेकिन धीरे-धीरे छोड़ूंगा." तो current धीरे-धीरे इससे निकलना शुरू करेगा. तो इसका मतलब क्या है? The current through this inductor will start rising like this. Understood? The current through the inductor will start rising like this. Huh? Okay, I suppose you understood. This is the time axis. Okay, and this is the amplitude. Current starts rising. So current will start rising through this inductor and it will go through the transistor and will come like this. IV is being supplied. Understood this point?
Yes, sir.
Yes, sir.
Now be careful. Now that this core is same for both. So that is this coil are like 3 windings of a same transformer. So the voltage in this is rising. See, because the current is going through this, the magnetic flux is increasing. This magnetic flux is linking this coil. So there will be voltage induced in this coil. Correct now?
Okay. Yes, sir.
Transformer, there is like voltage is induced in the coil. Now the winding is such that as the current is increasing here, this becomes more positive than this. That is how the winding is made. You can either wind like this or like this. So if the current is increasing here, that is, if the current is increasing here, this voltage is increasing. Correct?
Yes.
Transformer action. So now you see, that means now there is already VBB. So it is because of VBB, the current is IB. Plus now this voltage is added to this. So that means now this voltage plus this voltage is coming in this circuit. That means this current IB will also increase. Correct?
Right. Yes, sir.
So what you have to see is if this current increases, this voltage will increase and therefore this current will increase. If this current increases, again this current will increase. Again this current increases, again this voltage will increase. Again this voltage increase, again this current will increase, and that will keep on going. So IC will start increasing, okay, and if you take IB, okay, IB will also start increasing. Correct?
Yes, sir. Yes.
IC is increasing, IB is also increasing. Is it clear?
Yes.
Yes, sir.
Great. So both are increasing, Now you look at this voltage. Right? You look at this, you look at what is going to happen here. So IB keeps increasing, IC keeps increasing. Okay? Then can it continuously happen? Can it happen continuously? Is there nothing to stop it? Or at some point it will stop? Will it infinitely keep on increasing?
It can increase infinitely because that diode will get affected.
No, don't worry about that. Don't worry about that diode will get affected. Electrically, now you see this arrangement. Can it infinitely increase? Or is there something to stop this?
The inductor will provide backing.
Inductor will provide?
Backing.
Inductor will provide backing. That will depend upon the rate at which the current is rising.
Yes.
The rate at which the current is rising, that will depend upon the self-inductance will depend upon the rate at which it is rising. Right?
Yes.
So here it starts rising. It starts rising here. The collector current starts rising. Okay. So this is going to happen. So yes, there is some back EMF. There is some back EMF to begin with. At this point, there is some back EMF. Maybe that same back EMF will continue to be there. So what? Is there some mechanism that this current will start reducing or something? So the current is increasing, that voltage is increasing, this will increase, this will increase. But will they keep on increasing? They will not keep on increasing. So there is something to say, well, Mr. Current, you cannot increase further. Something should happen. Something should happen. Tell.
That sum of PGDBA and that this one, sir. Induced voltage due to that inductors of sir. If that exceeds VCC, sir, then it will get forward biased and.
You are coming to the point. Good. That is the way to think. So when this voltage now increases, because this voltage cannot go beyond VCC, isn't it? It cannot go beyond VCC. But this voltage, if it tries to go beyond VCC, then what happens? The transistor starts entering the saturation region. You remember the output characteristic of the transistor? IC versus VCE. So here you see we had graph like this. Okay. So now here you see you remember this is VCE. So if now VCE starts, so here what is happening here? VCE. So VCE maximum VCE is what now? VCC. Okay, VCC. Now when it reaches VCC, okay, and this voltage keeps on increasing, then you know the transistor will come to this region. This is the saturation region. Okay, understood? So see, I wanted you to tell this and you told it. Wonderful. So now, if it reaches saturation region, that means the collector current will, now there is some base current flowing here and there is some collector current flowing here. Now it has reached the saturation. So now if the base current tries to increase, the collector current will not increase. The collector current will lose control. The base current cannot control the collector current. Got it?
Yes, sir.
So the collector current now is fixed. The collector current now is fixed. That means the current here is not rising for a small moment. The current is not rising. And if the current is steady here, the magnetic flux is also steady here. And if the magnetic flux is steady, then this will not get induced. Because this will only get induced if there is a changing magnetic flux. And therefore, this voltage will start decreasing. That is, this voltage will start decreasing. Got it?
Should decrease suddenly?
Suddenly, no. At that instant, at some instant, you know, when this current gets saturated, this voltage will become zero. I mean, the induced voltage will become zero because the current is not rising. Got it?
Yes.
And therefore, this suddenly loses this voltage, and only this voltage, this VBB has to sustain the current. Got it? Then if IB now decreases, because now what happened, this voltage went off, there was some IB, now this IB now suddenly decreased. Got it? Now if IB suddenly decreased, then what happens if IB suddenly decreased? Now once again this becomes reverse bias, and now this current is now in a decreasing mode, IC will also decrease. Got it?
Yes.
IB will suddenly decrease, then IC will also decrease. Got it?
Yes.
Now if IC decreases, that means this current that was flowing here, see here, this current that was flowing here, at the instant when IC became saturated, that means no longer IC here will increase. But there is some IC that is going here, but this IC cannot increase further. Then what happens? This current will now start going into the capacitor. Got it?
Yes.
And then this capacitor will start getting charged in the ulta direction. Okay, this capacitor will start getting charged in the ulta direction, and now the capacitor voltage will build up like this. And this IC current will slowly become zero. Because the base current is now going in the opposite direction. It is not increasing, the base current is decreasing. Correct?
When the base current, it will decrease or base current, like it can't be zero.
No. Base current starts decreasing, this collector current will start decreasing. That point you got? Now, see here, the voltage induced in this inductor is what? Di by dt. When di by dt is positive, the voltage is in one direction. When di by dt is decreasing, see, still the current is in the upward direction, but it is decreasing. It is not the amount of current that is flowing, it is the rate at which the current flowing and in what direction it is flowing. Now the rate starts decreasing, so the voltage here becomes volta. Correct? So the current starts now flowing into the capacitor, and you know the capacitor now will start getting charged in the opposite direction, and this inductor current will slowly become zero, but it will not stop at zero. You know what happens in a RC tank circuit? Because this inductor will not allow current to die, it will continue to pull more current, and then this will become plus VCC and this will become minus. So this acts like a LC tank circuit. At that instant when it is complete, there is no current flowing here. IV will go on decreasing, and IV will only be, see, please understand here, IV will become zero. Why it will become zero? See, if this voltage, this inductor, the rate at which the current is flowing in the inductor is in the opposite direction, then the magnetic flux which was in this direction will now be in the ulta direction. So now this will become negative, this will become positive. So there can be a point where this voltage plus this voltage plus this voltage is zero. So IV will become zero. Correct? Then IC is zero. Now, finally when this capacitor is fully charged, no current is flowing in the inductor. No current here, no current here, no current here. No current. Now what happens? Again this will start sending current in the ulta. Again this transistor will start getting base current, and again this current will rise. Again the same phenomena will repeat. So that is how you know this oscillation is sustained. So this is fed in phase with this. So there is positive feedback coming here, and the transistor action takes place, and that is how you are going to get sustained oscillation. So this current will rise, it will fall, it will rise, it will fall, and the base current will also rise and fall and rise and fall, and therefore you are going to have sustained oscillation. And the frequency here is given by 1 by 2 by root of LC. Okay? Don't worry. You may not understand in one step. Now this is beautifully given in your NCERT book. Very nicely given. Go through that book today, and still if you don't understand something, just tell tomorrow, sir, I didn't understand this point. Bring the textbook to the class and you ask, pinpoint and ask. I will explain once again. Don't worry. If you are not understood completely today, don't worry. Try to understand as much as possible. I am sure that there can be some questions. Tomorrow, definitely I will clarify. Now, something you have not understood, I will teach you. Go through it. I know. When I studied this for the first time also, I had my own questions. I went back, I studied, I had few doubts, I asked my teacher, he explained. Oh, so same thing will happen. Just be cool. Okay?
That VCC is present or present, sir?
VCC
so
is...
why will it let the capacitor get charged in reverse? Like?
See, that is the basic thing. See, now, assume, you remember when I taught you this, you remember one fine day, I had written a circuit like this. Okay, this is S1, this is S2. Okay, remember this? Okay. First I close S1, and S2 is open. So if I close S1, what will happen? And keep S2 open, what will happen? Capacitor will get charged to VC. Correct? If I close this. Okay, first operation. Now what I do? Once this capacitor is charged, I will now open S1 close S. Then what happens? That is, I have closed this, I have opened this. Then what happens? This capacitor will start discharging.
Okay.
Hello, are you with me?
Correct.
So then the capacitor will start discharging. Then the charge here becomes 0. Agreed?
Yes, sir.
But the current here has not become 0. When the charge here is 0, the current is still flowing like this.
Yes.
Inductor will tell, I will take the current. So inductor will pull, the current in the inductor will start lessening, but it will pull more charges from here. So therefore, this capacitor will become pulled down.
Yes, sir.
Then again the same thing. So current keeps going like this, and you start getting the oscillations.
But here, sir, the VCC is always connected to that.
Let it get connected. So what is the problem? See, that is the beauty of this LC. VCC is connected. So what will VCC do? It will send that much current or that much energy which is lost in this inductor capacitor. See, this inductor capacitor and this transistor are not Mahatma Gandhi. They will be dissipating some energy.
Yes,
That whatever energy is dissipated by this is replenished by this. Just like how in the swing you were doing.
sir.
The oscillation is sustained by this fellow only.
Yes.
So in your brother's swing, the oscillation is sustained by what? Length of the spring and gravitation. Frequency F is equal to root of L by G. 2 pi root of L by G. Correct now?
Yes.
And here it is LC. That's it. Okay?
Yes.
Shall I proceed?
Yes.
Okay.
How do you justify that? Like, how it will increase the same way it will decrease?
How it will increase the same way it will decrease means what?
Like, the graph will be like perfect, like sinusoidal.
No, perfect sinusoidal no. That part I will tell you. Perfect sinusoidal part I will explain that to you. Perfect sinusoidal no. See now, understand this. At least you understood there is oscillation.
Yes.
At least you understood there is oscillation. Understood now? Now you see this LC combination. What this LC combination do? This is also what LC tuned circuit. And eventually what happens? The frequency here will become what? Resonant. See, you remember we derived this formula for that a LC tank circuit is resonating. So this will start resonating. Now listen very carefully. So frankly speaking, your question is very good. So why should this be sinusoidal? That is your question? Your question is very correct. So there will be many sinusoidal signals to be verified. Many frequencies will be there. Hello? There can be many frequencies. Frequency 1, 2, 3, 4, many. But when you have this combination, the dominant frequency will be this. Other frequencies will become insignificant. So for all practical purpose, it is a sinusoidal waveform. Got it?
Yes.
That is the thing. Any such doubts? Shall I proceed? Your time, man. You want me to go on teaching this? If you give me green signal, I'll go ahead. Otherwise, I will also stand.
Yes, sir.
Okay, fine. Beautiful circuit. Aram se read. If you still have doubt, I'll explain to you. Okay? I will not rub this board. I will keep it as it is. So tomorrow also, I can once again use this. Right. So now, quickly answer this question. Why is a transistor so called? So I think we have discussed this yesterday because there is transfer of resistor. Correct? Hello? Can we take a short talk toward transistor is in low resistance, output is taken high resistance, thus the transfer current from low resistance part to high resistance part. And I have explained this elaborately for all. Got it?
Yes, sir.
See, these are all the questions that are asked in some examinations, or they have abstracted some numericals out of these questions. That is why I am asking these questions. The base of a transistor is lightly doped. Explain why. Did we discuss all this yesterday? Right. So why? Because the transistor majority carriers force from emitter region move towards collector. The base is made thick, then I will do, then the majority carriers from emitter will come. I hope this aspect also I had explained, and it is nicely put in words. Right. Shall I continue?
Yes, sir.
Explain why emitter is forward biased and collector is reverse biased in transistor. Okay? Okay. Tell in your own words, why is this? So emitter is forward biased. So you generate a forward bias current flowing from emitter into base, and then when you make the collector reverse biased, that is collector base junction reverse biased, then these majority the minority charges in the base. The minority charges in the base is nothing but the majority charges from the emitter which has been injected into the base. And because of the reverse bias of the collector base junction, this is swept across. This is swept across, and that means now this current now starts flowing through the high resistance path between the collector base junction, which is reverse biased. Okay? The collector base is reverse biased, and therefore facilitating the current generated in the low resistance region to flow into the high resistance region, giving rise to current. It's a voltage controlled current source. Voltage controlled current source we are able to achieve by this. Right? That is it. Another way to explain this is that, we are creating what is called as a potential well. A potential well. If you remember, the day, the potential energy barrier. For an unbiased transistor, the potential energy graph will be like this, unbiased. For a biased transistor, you will have it like this. So you are creating what is called as a potential well, and facilitating, and because of this potential well, because you see you are using the transistor like this, you are able to facilitate the effort that you put to create a current in the base emitter region, which is having very less resistance. Now that current you are making it to flow through high resistance region. Okay, right. Okay, done. Okay, so